let's look at a clever way to find the tiny hidden flaws that can threaten our entire power grid.
You know, these huge failures often start with something so small you'd never see it with your own eyes.
A resistance change this small, 20 millionths of an ohm, can kick off a total system failure. It's wild.
See, that invisible flaw acts like a tiny heater, slowly cooking the connection until it completely melts down. These are microscopic changes we're talking about. So the big question is, how can you possibly measure it?
Your standard multimeter just can't see it. Its own test leads actually hide the very fault you're looking for.
So how do you measure just the connection? Well, this is where a really clever trick comes in.
It's a special technique that uses 4 wires, and it's designed to get a perfectly pure reading every time.
Here's the magic. 2 wires send the current, and 2 totally separate wires just measure the voltage.
Because those measurement leads have no current, they only see the component's resistance. It's a pure reading.
Okay, but a single perfect measurement isn't enough. A number like 45 micro-ohms is meaningless by itself.
You need a baseline to compare it to. This is the brand new reading for that specific part.
Then, over time, you compare new readings to that baseline to watch how the connection is aging.
And this is how you turn that data into real decisions. It creates a simple, clear action plan. You can see how this builds over time. A slow rise is normal, but any sudden jump is a red flag.
So the rate of change is just as important. A connection that's degrading fast needs attention right now.
Of course, all this trend data is useless if your measurements are bad, so let's avoid common errors.
For instance, are your readings jumping all over the place, or do they just seem way too high?
It might just be a dirty or loose probe. Always make sure you have a solid, clean connection.
Now, what if your readings seem suspiciously low? This can actually be an even more dangerous problem. That could mean a parallel path is stealing your test current. You have to completely isolate the component.
And look, Kelvin testing is just one powerful tool. It's part of a much bigger diagnostic toolkit.
Again, it all comes back to this. It's not just the reading today, it's how fast that reading is changing. Just imagine if we could see the health of every critical connection. This simple method gets us there.